Hi guys, a video on solving quadratic equations. Previously you might have done some solving of linear equations where pretty much you use inverse operations to move all the unknowns to one side and all the numbers to the other, and then you work backwards to find what the unknown is. With quadratic equations, however, we have a problem because we have, so if you have a look down here at this first one, x squared and 5x. So the powers of x are different. Okay, so you're going to have two different degrees of the power of x. Okay, which doesn't let you use inverse operations. So what we can do is we can use something called the null factor law. The null factor law to solve quadratic equations. So what that states is, what that means is, and it's a little bit hard to imagine, but if the product of two or more numbers is equal to 0, so say we have two numbers a times b, okay, if that is equal to 0, okay, then either a or b or both are 0, okay, because to multiply two numbers together to equal 0, one of the numbers has to be 0. Okay, so you know your 0 times table, anything times 0 is 0. So, so either A, B, or both are equal to 0. Okay, so that's called the null factor law. Null means 0. Factor is obvious. Okay, so look, it doesn't seem like a terribly useful rule just by looking at it like that. But when expressions are in factor form, so when we factorize something and we make it equal to 0, we can actually solve it to find out what x is. Okay, so find solutions. So let me show you how it works. I've got some example problems here. So we're going to use our factorizing skills to factorize and use the null factor law. Okay, so I'll just do, okay, so the first one here. All right, so we've got a quadratic. There's x to the power of 2 and groups of x. Okay, we can't reverse any the equation. It's a quadratic. So the first step is to factorize. Okay, so factorize using the highest common factor. You should hopefully recognize that the highest common factor in this one is going to be x. Take x out, and what we're left with is x minus 5. Okay, so I factorize it. Now this takes the form of, okay, so we've got two numbers multiplied together. So you could think about this as a times b. Okay, equals 0, just like in our null factor rule. Okay, so our number a is x and our number b is x minus 5. Okay, so what the null factor law tells us is either this is going to be 0 or this is going to be 0. All right, so what we do is we list down our possible things that x can be. So x can be equal to 0 in one case, or x could be equal to, x minus 5 could equal 0. Okay, so in the first one, this often in a lot of times in these questions you get two answers. Okay, there's a good reason for why x does have two solutions. We visualize that a bit better in the parabolas unit. So just bear with us. Just keep in mind that there can be two solutions to this, and there often mostly is. Okay, so x is equal to 0. That's one of our solutions. Now we haven't quite got x on its own here, so we have to do a bit of solving. So x minus 5 equals 0. To solve this, I plus 5 to both sides. Okay, because this is a simpler linear equation, so I can solve it using the inverse method. And I've got two solutions for x. Okay, so x, the answer to this will be x is equal to 0, or often just listed out like that, 0 or 5. Okay, so two solutions to x. I'll do another one. Okay, now in this case we've got x minus 2 equals 13. Okay, so again, it's a quadratic. it's got x to the power of 2. Now, you should recognize this as a difference of perfect squares. Okay, so I've got, the way I would factorize this is x minus square root of 13, x plus the square root of 13, and that's equal to 0. Okay, so previously we were only working with expressions, now we're working with equations which should be able to be solved. Alright, so in this case we've got our a times b equals 0. Okay, so on one hand we have x minus 13 equal to 0, and then in another case we have x plus 13 equal to 0. Okay, so solving these, I plus root 13 and from one side, and both of those, they cancel out, and this leaves me with an answer of x equals the positive square root of 13. Okay, if I do the same thing on the other side, I'm going to minus 13, root 13 from both sides. That cancels that out, and oops, x equals the negative square root of 13. Okay, often in cases like this, we'll say x is equal to the positive and negative root of 13. Okay, so that's a way of putting two answers into one. Okay, so that's using that was using the highest common factor method, this one here, to find values or solutions to x. Okay, and this one was using difference of perfect squares, which we've done in previous topics. Okay, now I'll do a few of these ones. Okay, so again, no highest common factor. There is no difference of perfect squares. This is a monic trinomial. Okay, so you factorize a monic trinomial, which we've done. Okay, so it's going to be x plus something, x plus something. Okay, so think of factors of 6 that add up to -5. So we're talking, it's going to be probably -2 and -3. It's going to definitely be that. So we're going to have x minus 2, x minus 3 as our factors. Okay, now these are a and b, and that's equal to 0. So a or b is equal to 0. X minus 2 equals 0. Solve to give us x equals positive 2. Now x minus 3 equals 0. Solve to give us x equals positive 3. Okay, quite often I just put a little rectangle around the answers just to make sure that we know what our solutions are. We have two solutions in this case. Okay, this one here, again, this is a monic trinomial. Okay, monic trinomial. Look, one of the reasons why we would we're learning all this factorizing is to solve these equations. It's one of the aims of this unit. So this has all been leading up to solving. Okay, so factors of 1 that add up to 2 is going to be plus 1, and x plus 1 equals 0. Now, if we, in this case, x plus 1 is equal to 0, and x plus 1 is also equal to 0. So you might be able to see that this is a perfect square. Okay. Now, when you solve perfect squares, you will find that they only have one solution. So some quadratics have two. Perfect squares have only one. Okay, so you don't need to bother with this one here. It only has one solution at x equals -1. Whoops. Okay, because both the solutions work out to be the same. I'm going to stop this video and I'm going to do the next one with some of the more complicated ones.